Okay, I'm going to talk about finding the length of an arc length. Okay, arc length is if I'm going to measure the length. Remember, length is distance, right? If I'm going to measure the distance from, here's the measurement of arc AB, okay, from here to here. If I'm going to measure that arc, if I were to take a string, right, and measure from here to here, and then measure it on a ruler, how far are those 2 points? Okay. There are different ways to do this because really you can use a proportion. It's a part of a whole. But because it's a part of a whole, you can think of it as finding a percent of something, of is times, right? And length is distance from here to here. So remember, the one that's the distance around a circle, that's the perimeter, the circumference of the circle. So we're going to go and use our circumference formula. I let you use your formula sheet so you can look here. Okay, circumference is 2 pi r. You don't have to memorize this. So really, I'm going to teach you to just find C for circumference. Arc length is going to be the percent of the circumference. So what do I mean percent? Well, percent is part out of 100. That's how you do a percent. But for us, it's part out of a whole. So our part is the measurement of the arc we want to find, right? So here it's going to be 60 over. Now, length around a whole circle, or measurement, sorry, in degrees around a whole circle is always 360. Right? Okay, so we're going to multiply that by, and now we're going to do circumference. The one here says 2 pi r. Again, it depends on if we had the radius or the diameter. We look at our circle up here, they gave us, okay, that's the radius, right? That was from the center out. That's the one that has the r on it. So I'm going to use the first one, 2 pi r. So 2 times pi times the radius is 12. Okay, and I just put all that on my calculator. That's going to find the arc length. So let's see, what was it? 60. 60 divided by 360. Okay, I can put parentheses around that, but order of or PEMDAS, order of operations, is going to do that division first anyway. Times the circumference was 2 pi r, so 2 times 12. 2 times pi times 12. Okay. Again, if I'm looking for a multiple choice answer, let's see, sorry, I'm going to make that a 6. I'm going to go to the nearest tenth. If I finish at the 10th place here, it's a 5, but the next number is 6, so it's going to go up to a 6. Goes up 1. Okay, now, the person that made this worksheet did 2 examples, so you understand, you know, the bigger your circle is, what do you think is going to happen? This has the same measurement. The part we wanted had a degree measure of 60. Right? So the measurement of that arc was 60, the central angle was 60, the arc was 60. Alright, so we wanted 60 out of 360, and we used circumference. Well, here was 12. What's going to happen on this one, right? It's 20. It's going to be bigger. So over here, remember, I'm using a ruler to measure this, so this is still in millimeters. Alright, the only difference over here is now it's 60 out of 360. Okay, that's my percent, and I'm going to multiply that toward times the circumference formula. 2 pi r. I look over here, 2 pi, and the radius this time is 20. You know, if I don't hit times, it knows that I'm doing multiplication. Okay, yep, it got bigger. Now when I go to the 10th place, I stop here. The next digit is a 4, so it stays 20.9. I round down to, okay, and this is millimeters. Okay, so again, if you're writing down what you did on your paper, it's 60 out of 360. That's the part of the whole that I want. Okay, percent is just part out of whole. And then I'm multiplying that by 2 pi radius. Okay, again, if I'm looking at a multiple choice answer and I don't see this, this decimal that I just found with my calculator, you know, look at your answer choices. If they have pi, you just have to figure out which one's right. You know, you haven't done anything wrong, you're just in a different format. Okay, so let's do a couple more examples together from this practice. Alright, you can screenshot that there if you don't have your worksheet. Okay, so arc length, the directions for all of these is saying, okay, find the arc length, the length of the arc. So if I'm doing length, I'm going to use circumference. So I might, you know, write down the formula. Again, I don't have to memorize this, guys. It's right here on my sheet. You know, I let you use this on every test. So you can write, honestly, I almost always do the first one. That way I'm always in the habit of finding the radius, because for area you need the radius. Alright, so I'm going to use the radius here, EF, the length of arc EF. Notice there's no M in front. The measurement, let me write this with a different color. The measurement of arc EF, that's the same as the central angle, right? That's 100. Okay, but that's not what it's asking. The directions said the length of the arc. Alright, so I'm going to come over here. I want to do, this is going to be 100, so I want to do 100 out of 360. Okay, that's the part of the whole that I want. And I'm going to multiply that by my circumference, 2 pi. Do I have my radius? Yeah, this is the radius. Always double check that you're using the radius if you're going to use this formula. 4. Okay? And I just put it in my calculator. Obviously I'm not putting in those degrees. By the way, how did I know it was the short distance? When it's 2 letters, remember that's always the closest. So it's not that way, it's from here. I'm finding the length here to here. Shortest distance between those 2 points. Alright, get your calculator and just type that in. 100 over 360, multiply it by a circumference, 2 pi, the radius was 4. Okay, these are annoying. When you're going to the tens place here, what happens is this 8 makes that actually 10, so it becomes 7.0. 6.9 is approximately very close to 7.0. And this is meters. I'm using a ruler, so it's, or a, you know, measuring tape or whatever. Okay, here, let's do this one. Let's go and do one more. This is one I always get questions on because, you know, oh wait, there's no numbers. Another issue is, you know, there's 3 letters. Which path do I go? Again, everything in geometry, the symbols are what they are. So I'm following an arc here. I'm not following an angle, right? It wasn't out front. Alright, and I'm also not finding the measurement, but that's going to be my first step. The measurement of start at W, end at Z, go through X. Start at W, end at Z, go through X. So this way. So the measurement of that arc is the first thing I need to find. Alright, oh my god, there's no numbers, panic! Alright, wait a minute, doesn't that mean something? Okay, so from here to here, you know it's 90. And from here to here, what's that? You know, that's a diameter right there. So this arc right here is a semicircle. That's 180. So we're finding the distance. So this is going to be more than half the circle, right? This is 180. I can do this either by adding those, 90 plus 180, 270. Okay, or I could do it by, I mean, if that's 90, this is 90, right? Because that's a linear pair. So, you know, I could have done 360 the whole circle and get rid of the arc I didn't want, the 270. Okay? Or get rid of the 90. Alright, so that's my first step. So now I've got to do one more thing because I'm not finding the measurement, right? I'm asked for the arc length and the directions. Arc length. Length of the arc, the distance. Alright, so distance is circumference. So I want 270 degrees out of the total 360 times the circumference. 2 pi, and what's my radius? Oh shoot, I didn't do that yet. Make sure you're always using the radius. Common mistake on this one is people are going to put a 10 there. Remember, your circumference, put this over here, if you're using the first one, radius is from the center out. This is in the middle of that. So 10, they're indicating that this is the whole length, which is the diameter. So if the diameter is 10, the radius is half of that, divided by 2. Okay, so I'm using 2 pi r. 2 pi, the radius is 5. Go to your calculator. I want 270 degrees out of the total 360. And I'm doing the circumference, 2 pi times 5. Alright, if I go to the nearest tenth here, that's where I'm finishing, but I want to go to the closest tenth. So 6 is big, I'm going to go up to 1. One more is 6, 23.6. And what am I doing here? Feet is my unit of measure. It's one-dimensional. Okay, go try some more.